Hello everyone. On this video we will be looking at properties of continuity. Alright, so to get started, what if we let B represent any real number? Okay. What if we also know that f of x and g of x are two continuous functions? Okay, and they're continuous at some point C. Then the following are also continuous. Okay, so the first one be the scalar multiple. Okay, the scalar multiple B times f of x, or B times g of x, whichever one you want to use, is also continuous. Okay, so for example, let's say if you have f of x equals sine of x. Okay, we know it's continuous because we can actually draw the graph for f of x equals sine of x without raising our pencil. It's just a complete sine wave, one continuous function. There are no values of x that would make that undefined. Okay, so we know it is continuous. And so is, let's say, h of x equals 8 times sine of x. Or it could be 1/2 times sine of x, or it could be 0.3 times sine of x. Okay, any scalar multiple of sine of x would be continuous also. Alright, so now let's look at the sum or the difference. Okay, so we know that f of x and g of x are both continuous. Okay, so we know that f of x plus g of x and f of x minus g of x are both continuous. Alright, so let's say, for example, if you have f of x equals x, and if you have g of x equals sine of x. Okay, so we know both of those are continuous. You draw f of x equals x, it's just a horizontal line through the origin, and sine of x, we know that's just the graph of sine. Okay, so we know they're both continuous, are both continuous functions. Okay, so what does that tell us? So let's say if you have h of x will equal x plus sine of x, and let's say if you have some h of x equals x minus sine of x, or it could be sine of x minus x, it doesn't matter. Let me clean that up a little bit, give that a little more room. x minus sine of x, okay, are also both continuous. Okay, so adding and subtracting two continuous functions will give you a continuous function. Okay, so we'll continue this on the next page. If you're still writing, feel free to press pause, but we're going to go ahead and move on. Okay, so number 3, we look at the product or multiplying of two continuous functions. So let's say f of x times g of x is continuous. Again, assuming that f of x is continuous and g of x is also continuous. Okay, so for example, let's say if you have f of x equals sine of x and g of x equals cosine of x. Okay, both of those are continuous. Again, you can draw them without lifting your pencil up. And what does that tell us? That if you have some h of x equals sine of x times cosine of x, this is also continuous. Alright, now we've done the adding, subtracting, and multiplying of continuous functions. What about dividing? Okay, well, division of continuous functions let's say are not always true, are not always continuous. Okay. Now, if you have something like sine x divided by 5 or cosine x divided by 0.3 or something like that, yes, it would be continuous. Okay, because there's no possible way that that denominator of 5 could be magically turned into 0. Okay, it's a constant. It's not going to change. But let's say, for example, you have f of x, again, equals sine x, and g of x equal cosine of x. Now let's say we decide, okay, we're going to go ahead and divide it and see if we get a continuous function. So let's say if we have h of x equals sine of x over cosine of x. Okay, this would not be continuous because there are too many values where cosine of x could equal 0. So we know that x couldn't equal pi over 2 because cosine of pi over 2 is 0. Couldn't equal 3 pi over 2 because cosine of 3 pi over 2 is 0. Couldn't equal 5 pi over 2 because cosine of 5 pi over 2 is 0, and etc., and so on. Okay, so that's why the division of two continuous functions are not always continuous. It might be sometimes, but not always. Okay, now it would be continuous if you had an interval, let's say, between these two. Let's say if it was between pi over 2 and 3 pi over 2, then it's continuous in between those points. But just continuous overall, it would not be. Alright, so hopefully this video made sense, and I will see you on the next video.